Hi, welcome back to interQiew.com. I hope you enjoyed the first video and found it helpful. In this video, we will look into the code of the second question from the first C++ test on interQiew.com website. Let's get started. At the beginning of the code, we have a polymorphic class A. Polymorphic means that the class has at least one virtual function. Inside class A, there is a default constructor that initializes its data member, a virtual function f that returns the data member, and a virtual destructor. Although destructors are not the focus of this program, it's a good practice to declare the destructor of a polymorphic base class as virtual in order to ensure proper destruction and the allocation of objects and sub-objects. The data member of the class A is protected, which means it is accessible inside the derived class. Class B is derived from class A and has its own default constructor, which calls the constructor of the base class. Virtual function f of class B overrides virtual function f of class A and returns the data member derived from class A plus 1. In the main function, there are 4 calls to function f, and for each call we need to figure out whether it is function f of the base class A or derived class B is called. At the beginning of the main function, one const object of class A is created, and one const object of class B is created. Then we have array x of 2 pointers to const object A. The first element is initialized to the address of object A, and the second element to the address of object B. Note that the address of object B is a pointer to const object B. Compiler implicitly converts it to the pointer to const object A, since B is publicly derived from A. Next, we have vector y of objects of class A. We use type def for the vector to keep the name short and use it later. The vector y is created by constructor that takes initializer list object. It is new in C++ 11. Initializer list is a class that wraps an array and provides interface to access it. Compiler automatically creates an initializer list object by copying the values provided in the brace list into a temporary array of objects of class A. Then the constructor of the vector takes the initializer list object, iterates over all elements in the array, and copies them into its internal data structure. As you may have noticed, using initializer list in this case is not the most efficient way of creating the vector, since the objects in the list are copied twice. One time to create the initializer list, then the second time to create the vector itself. A more efficient way would be to use reserve function of the vector to allocate space for 2 objects. Then use pushback function 2 times to add the objects to the vector. However, we used initializer list here to keep the program short. Whichever method we use to initialize the vector, at some point the objects A and B are copied to create new objects of class A. When object B of class B is copied into an object of class A, object slicing occurs. Object slicing happens when an object of a derived class is copied into an object of a base class. The resulted object loses all the properties of the derived class, since it does not have any data members or virtual functions from the derived class. On the next line, a const iterator is defined that points to the first element of the vector. Then we have 4 calls to function f, 2 using pointers of array x, and the other 2 using iterators of vector y. Since function f is virtual, at runtime all these calls are binded to a specific function f based on the underlying object. In the first call, the function is binded to the function f of class A, since the first pointer of the array x points to the object A. The second call is binded to the function f of class B, since the second element of array x is a pointer to the object B. In the last 2 calls, function f is called using arrow operator of the iterators to the first and the second objects of the vector y. Although the syntax of calling a member function via pointer and iterator is the same, there are 2 calls occur when overloaded operator arrow is used. The first call when the operator arrow of the iterator returns the pointer to the underlying object. Then the second when function f is called using that pointer. Since the underlying objects of the vector y are of class A, for both iterators the called function f is bounded to the function f of the class A. Now, as we're done with the second question, you can visit interQiew.com website and check the question. Thank you for watching this video and subscribe for our channel for more videos.